All right, you ready for part two? Yeah, I'm recording it the same day. It's fine. Okay, so let's talk about these two first, and then we'll do some example problems with them. I was gonna pause and then talk about it, but there was a train, so I just wrote it all out. Okay, so the first one is side-side-side similarity theorem. So if the ratio of all three sides are proportional to all three sides of the other triangle, then those two triangles are similar. This is kind of what we saw last time. And then side angle side says that if I have an angle and then the two sides like flanking it, it has to be side angle side, just like in chapter 3, side angle side. Then those two triangles are similar as well. So I have two more options other than AA, similarity theorem. So let's use them. All right, so I'm given these two triangles and I want to figure out if they're similar. Well, I already kind of see that I have a side angle side sort of situation going, right? Because I have a side, an angle, and a side. I don't know anything about this side. I don't know anything about those angles. It's all a mystery to me. So I'm going to try to see if side angle side similarity theorem works, which means I need to figure out if this ratio and this ratio are the same. So I can do that in a couple of ways, but what I'm going to do is I'm going to take one divided by the other. So let's start with the bottoms because they're probably the same. Like it's the bigger one of the two, right? So I'm going to do, let's do 28 divided by 21 and just see what that is. Hold on, I don't know. The notes I'm using did it the other way. It doesn't really matter. I got 1.3 repeating. Okay, let's try it with the other one too. We have to check to see if they match. Okay, so I do 24 over 18. I have to keep them the same. Big over small, right? Big over small. There's the train again. Let's see, 24 over 18, 1.3 repeating. Okay, so I have a side angle side situation, right? And these two numbers are the same, which is what I wanted. So I would say yes by side angle side congruency theorem, or sorry, similarity theorem. Hold up, boom, didn't even need to white out. So I would say that these two are similar, yes. Okay, let's do another one. Okay, so this is the most common version of the side-side-side similarity theorem. You can, if it asks you to determine, you can just do the same ratio and see that they're all 1.3. So we're not going to worry about that too much. You can totally do that. It's going to be an option, but you're going to be able to do it. The thing that's going to be the most common is finding the value of x that makes these two triangles similar. Well, what that means is that I have random x's here that I need to figure out what they have to be to make these two things be true. Well, there's a ton of different ways to do this. I'm going to show you maybe even two. I'll do at least one, but I'll show you two. Okay, so one way is to set up a proportion with the sides that we know. Now you can do 5 over 10 or 10 over 5. I'm going to go 10 over 5 because I prefer to work with whole numbers instead of fractions, but it's the same. Okay, and then I use one of the other two sets. I kind of like this one better because I like that better than the 11, but it doesn't really matter. So I'm just going to do 14 over 2x minus 1. And then once I find out what x is, I'm just going to plug it in here to make sure that it still works. I can kind of see that this should be times 2, right? 5 times 2 is 10, so this should be a 7. Okay, so I'm going to cross multiply and divide like I did last time. So if I cross multiply here, I get 10 times 2x minus 1. And if I cross multiply here, I get 5 times 14. Well, 10 times 2x minus 1 would be 20x minus 10. And then 5 times 14 is obviously 70. I should have known that actually. Equals 70. Well, then I can solve this like normal. I'm going to add 10 to both sides. And I get 20x equals 80. Divide by 20, x equals 4. Let's make sure that works. So I'm going to check it in here. This theoretically should be 22, right? 11 times 2 is 22 because 5 times 2 is 10. So if that's 22, then 5 times 4 is 20 plus 2 is 22. Yes, so I found the x value that works. I'm going to show you a different option. So here's an alternate. So the alternate is that I know that 5 times 2 is 10, right? So that's my k value. So I know that 2x minus 1 times 2 should be 14. And I can solve this problem a lot faster than I solved the other problem. Or I could do 11 times 2 is 5x plus 2. So then, okay, that's 4x minus 2 equals 14. Add the 2, 4x equals 16. Divide by 4, x equals 4. They're the same. I get the same answer both ways. So the value of x that makes these two triangles similar is 4. If you are confused, please tell me, email me, come to my office hours. I will help you out. I'm here for you. Okay. And I hope you have a beautiful day. Bye.